Now we are going to solve some question under mean, variance and standard deviation topic. And under this topic, we have chosen the first question from paper 9709/51 for the session May June 25. And question number 3 belongs to the mentioned topic. And part A and B of this question don't belong to our discussable topic. That's why let's see question number 3C. 3C says two other teams of runners, the Eagles and the Swifts, also took part in the event. The recorded times in seconds for 20 runners from the Eagles and 30 runners from the Swifts are denoted by X and Y respectively. So runners of Eagles are denoted by X and runners of Swifts are denoted by Y. It is given that sum of X is equal to 175 and that the mean of Y is 8.4. So two information has been given and we'll have to find the mean time of all 50 runners. So total time taken by, first of all let us write total time taken by first team was Eagles. Taken by Eagles. Eagles is denoted by X equal to, so as this is total time, so it will be sum of X. Okay, sum of X equal to, what is the total time taken by the Eagles, is given 175 seconds or minute, whatever. 175, it is given sum of X is equal to 175, whether minute or second the unit has not been mentioned, so let us write only 175 seconds. Okay, then total time taken by the Swifts, time taken by the Swifts. So for Swifts means Y, the total time has not been given. Look at this. It is mean time has been given. And if we want to find the mean time, we will have to multiply by 30, because how many Swifts? How many Swifts are there? 30 runners from the Swift. Look at this. 20 Eagles. 20 was Eagles. Number of runners in 20 was number of runners in Eagle was 20, and number of runners in Swift was 30. So mean time is given. It is not total. We will have to find. Look at this. This is the mean time. So if we want to find the total time, then we'll have to multiply by total number. So it is 8.4 into 30. 8.4 into 30 runners. 30 runners. So finally it is going to be, if we multiply 30 by 8.4, it is 252 seconds or minute, whatever you tell. We are supposing it to be in seconds. Okay, now we are going to find the mean of all 50 runners. Okay, now we can write mean is equal to sum of X, that means sum of all the runner time taken by all Eagles as well as sum of the all times, that means total time taken by Swifts, which is sum of Y, over total number of runners is 50. 30 plus 20, it is 50. We may write here N. So if we substitute the values, what is it going to be? 175 plus 252 252, which will be divided by total number of runners, which is 50. So finally our mean value is going to be, using our calculator, we find that mean time of all 50 runners is 8.54 seconds. 8.54 seconds. Okay, seconds or minutes, you may use any unit, or you can write only units. Let's see the next question. The next question says it is given that sum of x squared is 1823. It is also known that the standard deviation of the time taken by all 50 runners is 1.38. So standard deviation is given. Okay, let us start with standard deviation. Let us write standard deviation. So standard deviation is given. Standard deviation. Standard deviation is 1.38. So formula for standard deviation is square root over variance. Okay, so square root over, it is square root over variance. And what is the variance? Variance is sum of x squared plus sum of y squared over total number. Total number is n, and our standard deviation is given 1.38. After that, if we substitute the values, it is going to be n means 50. We know total number of runners is 50. So let us write 50, and sum of x square is given 1823. 1823. Sum of y square is to be obtained. Okay, so we will just leave it unchanged. Unchanged is sum of y square equal to, sorry, I made a mistake in writing the formula. Formula is sum of fx square plus fy square over n minus, we will have to subtract the mean value, square of mean value. Okay, square of mean value, and then our right side is 1.38. Well, now minus mean value, already we have found our mean. Let us see how much was our mean. Our mean value was 175 over 252 over 50. That means if we add up, it is going to be 427 over 50. 427 over 50, then whole squared. Whole squared, whole squared is equal to, and if we remove the square root from left to right, then it is going to be 1.38 square. So 1.38 square is 1.9044. 1.9044. Well, then if we substitute the value, if we take this value to the right side, it is going to be 1823 plus sum of y squared, sum of y squared over 50, over 50. If we transpose this to the right side, it will be definitely addition. Then we will have to get, it is using our calculator, we get 427 over 50 whole square plus 1.9044 equal to 74.836. 74.836. Well, now by doing cross multiplication, we can see that our 123, that is sum of y square, sum of y square is going to be 50 into 74.836. Then from left side 1823 will be subtracted. 1823. If we do so, then our sum of y square is going to be, let us use our calculator. It is 50 into 74.836 minus 1823 equal to 1918.8, 1918.8. Okay, so this is what the standard deviation of the given data is. So this is all about the solution to the part C and D of question number 3 of paper 51. Let's see the next question. The next question has been selected from paper 9709/52 for the session May June 25, and we are solving question number 5 under the same topic. The times taken T minutes by 300 students to travel to Hollowtown College are recorded. The results are summarized in the table below. Less than 10 seconds, that means 0 until less than 10 seconds, 10 less than 20 seconds, 30 seconds, and cumulative frequencies have been given. Okay, now we will have to find out the midpoints of each of the classes. Okay, so first midpoint is, this is 5. Okay, and then the next midpoint will be from 10 until 20, it is 15. Then 20 until 30, it is going to be 25. And then 30 until 40, it is going to be 35. Then 40 until 60, it is 50. And 60 until 90, it is 75. So our midpoints are 75. Okay, 5, 15, 25, 35, 50 and 75. Now we'll have to find frequencies. They have given the cumulative frequency. So first frequency is 34. Second one, from 84, if we subtract 34, it is going to be 52. Third frequency is from 142, if we subtract 52, it is going to be, sorry, if we subtract 86, it is going to be 56. 56. So 34, 52, 56. Then from 208, if we subtract 142, it is 66. Then from 265, if we subtract 8, then it is 57. Then from 300, if we subtract 65, it is 35. So these are the frequencies as well as midpoints of each of the classes. Now question number A is about frequency graphs, so we are not going to solve that one. We are going to find our mean. So let's see which question is talking about mean. Question number C says, calculate calculate estimates of the mean and standard deviation of the times taken to travel to college by 300 students. So all of the points we have already find the points. So midpoints. First let us write the midpoints. Midpoints are, what the midpoints we have already seen. It is 5, 5, 15, 25, 15, 25, 35, 50 and 75. 35, 50 as well as 75. 50 as well as 75. And then the frequencies are, let us find the frequencies. Frequencies are frequencies are, what are the frequencies we have seen? 34, 52, 56. 34, 52, then 56, 56, 66, 57, 66, 57, and finally 35 are the midpoints, I mean frequencies. So now easily we can find the mean. They have told us to find estimate the mean. So mean is equal to, hence our mean, what is the formula for mean? The midpoint into frequency. The formula for mean is what? Midpoint into frequency. So 5 into 34, 5 into 34. Or if I write the formula, I think it's not necessary for you to write the formula, because since grade 8 or 9 you have been continuing finding means, so it is unnecessary to be written the formula. We are just writing directly. So 15 into 52, 15 into 52 plus 25 into 56, 56 plus 35 into 66, 66 plus 50 into 57, 50 into 57, 50 into 57 plus 75 into 35 over, there are total 300 students, over 300. Using our calculator, we see that our mean value is, using our calculator we will find 5 into 34 plus 15 into 52 plus 25 into 56 plus 35 into 66. 35 into 66, not 56, it is 66. It is 66. 35 into 66 plus 15 to 57 plus 75 into 35 equal to 33.8 minutes. 33.8 minutes. So our mean value is 33.8 minutes. Well, and I think this direct answer should not be written. Let me write in fraction first. For more accurate answer, let us leave it first in simplest form, which is 1013. That is, numerator is going to be 10135 over, in common fraction let us leave this 300. Then finally we can write our mean value is 33.8 minutes. 33.8 minutes. Because if we require this information later on, we will have to write the exact value. Then the second one is we are going to find the standard deviation. Standard deviation, so SD is equal to, we know standard deviation is equal to standard deviation. The formula is known to us. Standard deviation is equal to f square x square, that means f into x squared. Again, I am not writing the formula, please don't get confused. Or if I write the formula, it will be, formula is SD equal to, SD is equal to sum of fi x squared over n minus mean value, mean means mu, okay, mu whole square, and all of them will be under square root. That means it is, that means standard deviation is the fi x square, fi into x square minus mu square, means mean square. That is, this is actually square root of variance. The formula of variance is sum of fi x square over n minus mean value, square of the mean value. So we are just doing so. So all the midpoints will be squared. Okay, if we square the midpoints, it is going to be 5 square into 34. So let us write 5 square into 34. 5 square into 34 plus 15 square into 52. 15 square into 52 plus 25 square. 25 square in 75 square into 35 over n. N is our total number of data is 300. Then minus, we will have to do subtraction, minus mean square. Our mean is 101 over 35 divided by, let me write mean, though space is very narrow, let it be written. So we have inserted all the information that standard deviation is the square root of variance. So what was our variance? Variance was sum of f square x squared, not fx squared, fx squared, means x squared into f, each of the midpoint square into our frequency, individual frequency. Then sum of that is going to be our variance, and from that we will have to subtract mean value, square of mean value. So using our calculator, we find that our standard deviation is going to be square root over 5 square into 34 plus 15 square into 25 plus 25 square into 56 plus 35 square into 66 plus 50 square into 57 plus 75 square into 35 minus 10135 over 300 whole square equal to 20.4 20.4 minutes is the standard deviation of this data. Well, it is not exceptional at all. It's as same as the previous one. Let's see the next question under this topic. The next question has been selected from paper 9709/53 for the session May June 25, and where we are going to solve the first question under the same topic. For a set of 40 values of x, it is found that sum of x minus k is 836 and sum of x minus k whole square is equal to 25410.8, where k is a constant. First question says, given that the mean of these 40 values is 124, find the value of k. So we should not forget that this is a coding data. It's a coding data. It's coding data. Okay. So for coding data, how will we solve this? We will first write, it's given that sum of x minus k is given how much? 836. So it is actually sum of x minus total, how many values there are there, how many x's are there? 40. So it is going to be 40k. 40k is equal to 836. Now if we simplify more, our sum of x is going to be sum of, so what is our sum of x? Sum of x is actually total value of all of these 40 numbers. So total values are, mean is 124, total number is 40. So total value of x is going to be 40 into 124 minus 40k is equal to 836. Hence our k is going to be, if we simplify and isolate k, our k is, hence our k is going to be 834, that is 4 into 124, that is 496. 496 minus 836 over 40. Hence, our value of k is going to be 100 or 103.1. 103.1. So this is the value of our k. So in coding data, remember sum of x minus k means actually sum of x minus 40k. Sum of k means actually 40. There are total values, total number of data is 40. So it will be multiplied by 40. And sum of x means actually total values, not mean value. Remember, sum of x is not mean value. This is the total value. That's why we have multiplied the mean value by total numbers. Then let's see what B says. The question number B says find the standard deviation of these 40 values of x. Remember, standard variation, I mean standard deviation and variance is not affected by coding data. So coding data doesn't affect. Let us write coding data. For mean, coding data is applicable, but for standard deviation variance, coding data doesn't affect it. Coding data doesn't affect standard deviation or variance. Standard deviation or variance. Well, so the simple formula we are going to apply for finding standard deviation. What is that formula? Our formula is standard deviation is equal to, as we did in the previous case, square root under that sum of x minus k whole squared over total number of data. Total number of data is minus mean whole square. So mean is actually, we know, sum of x minus k, sum of x minus k, or k can be substituted as 40. No, okay, a value is given, but we are going to use the exact values whole square. Well, hence our standard deviation is going to be, if we substitute the values, what is it going to be? Let us substitute equal to x minus k whole square is given. X minus k whole square is equal to what? This is x minus k whole square. X minus k square is 254108. Okay, and total number is 40. Already we have found this. So it is 25410. 25410.8 over 40 minus our x minus k over 9 is also given. We have used x minus k is 836. So it is 836 over 40. 836 over 40 whole squared. So finally our standard deviation is going to be, using our calculator, we get 14.1. 14.1. So what have we learned from this question? That for mean value we will have to consider coding data, but for standard deviation and variance the coding data doesn't affect this. That's why simply we apply the formula. Let's see the next question. The next question has been selected from paper 9709/55 for the session May June 25, and we are going to solve the first question, which says two fair six-sided dice with faces labeled 1, 2, 3, 4, 5, and 6 are thrown. The two scores are noted. The random variable x is defined as follows. If two scores are equal, then x is equal to 0. If two scores are not equal, x is the larger score minus the smaller score. That means it's subtraction between difference between the two scores. Draw up the probability distribution table for x, which has been solved under the topic probability distribution table. Let's see question number B. Question number B is at the bottom of this page. Yes. Find the find EX. EX means actually mean. Okay. And variance of X. So let us find EX. Formula of EX we know. X is equal to sum of Fixi over sum of Fixi over n. As it is probability given, so sum of X into probability of individual one will be multiplied by this over total number of participant or total number of outcomes. So total number of outcome is 36, because if two dice are thrown together, so 6 sixes are 36. Now from the probability distribution table we will find the product of each of the probability and X values. This is our probability distribution table. When X is 0, then our probability is 1 over 6. When X is 1, so let us substitute the values. First one is 0 into 6, 0 into 6 plus. Second one is 1 into 5 over 18, 1 into 0 into 1 over 6. Sorry, in the formula I made a mistake. It should not be divided by n, because already we are multiplying by the probability, so there should be no n. So it is simply multiplication of X value as well as probability, each probability. So first one is going to be 0. If we multiply, it is going to be 0. And second one is 1 into 10. So 10 over 36. 10 over 36. And the second one is 2 into 8. So 16 over 36. 16 over 36. Plus 3 into 6. 18 over 36. Plus 4 fours are 16, 16 over 36 as well as 10 over 36. 10 over 36. So if we use our calculator, we will see this is 10, 26 plus 18, so 44, 60, 70. It is 70 over 36. If we divide 70 by 36, it is going to be 1.94. So our mean value is 1.94. Now we will find the standard deviation, and you know the formula for standard deviation is also same. Standard deviation is equal to, sorry, not standard, variance. They have told us to find the variance. So variance is equal to variance of X. You know the formula is X squared sum of X squared into each of the probability. Okay, so we, instead of X, just we will make square. If we do so, what will it be? The first one is 0 as usual. First one is 0, and second one is going to be 1 square, so it is 10, again 10 over 36. 10 over 36. Then the third one is going to be plus it is 2 square. Okay, so 2 square 4, 32 over 36. 32 over 36. 36. Then fourth one is going to be 3 square 9. 9 sixes are 54, so 54 over 36. Then fifth one is going to be 4 for 16, so it is 64. 64 over 36. And final one is 5 fives are 5 square means 25, so 50 over 36. Next one is 50 over 36. If we use our calculator to simplify this, 10 over 36 plus 32 over 36, then 9 over 54 over 36 plus 64 over 36, 54 over 36 plus 64 over 36 plus 50 over 36, then minus our mean value. But where is the space to write our mean value? So let me rewrite this. Now it can be shown. So there are total 6 values, 1 2 3 4 5 6. That is x square into probability of each one has been multiplied with x squared, then mean square has been subtracted. So using our calculator we find that our variance is 2.05 is the variance. So that's all about this question. This is from the paper 55. So that is the last of all questions of under this topic. So with this one we are ending this topic.